Okay, let's take a look at chapter 3 in 5 minutes and see what we did this unit. So we have 3 different things we looked at. We looked at a scatter plot of data and we described it. We looked at a residual plot from that data to decide if the data was in fact linear, and then we looked at a computer output, most of which we ignored, except for that, to look at our least squares regression line, look at our S value and our R squared value, and find our R value if we want. So what have we done here? So if we look at this data, I would want to describe it first. So in terms of the direction, it is positive. In terms of it's going up, negative would be the other direction. In terms of the form, this is linear. In terms of the strength, it is pretty strong. Now, how do I know it's pretty strong? Well, the points are pretty close together. It doesn't look like I have any wacky outliers. Now, if I look at the computer output, I can square root. This is the R squared number. 69% or 0.693. I can square root that number to get my R value, which is going to be 0.83, which again tells me that's a pretty good R value. It's pretty close to 1. That would tell me it's a pretty strong relationship. Now, in terms of the residual plot, this has no pattern. So that means that data is probably linear. It looks pretty linear, but that'll back it up. Now, what's the equation for this data? Thanks for asking. So if I look at my computer output, I can find it. I can write this down. So y hat equals the constant, which is my y-intercept, 62.1, plus my slope, study time goes in front of the x, 12x. So now if I wanted to plug in stuff here, plug in any value, and that will give you a prediction. Now, if I wanted to know how good that prediction was, I would find the residual, which is the actual value minus the prediction. Now, how is this? Let's interpret this data a little bit. Let's talk about this equation of the line. What is the data doing? How's it changing? Well, let's look at the slope number. So basically, every time I study an extra hour, that's the x thing, study time, what will my grade be? It'll be 12% higher. So every time you study an hour, your grade goes up 12%. If you don't study at all, that's the y-intercept, your grade will be 62.1%, which is sad, so please study. If I wanted to further look at how good this line was doing, what would I look at? Well, to decide if my line is doing a good job, I can see how well it's making predictions. So that's these 2 values. So for the S, I would say, on average, the least squares regression line has an error of 7.7% each time it predicts. So every time I make a prediction, I'm off by 7.7% in terms of the grade I would have based on my study time. Now, for the R squared value, that's the distance between your points and your lines, and how much of that distance you're comfortable with and how much of that you can account for, meaning like we're okay with some of that space. We can account for about 69.3% of our space. Let me erase that so you can see it better. We can account for the space between my points and my line. There's 69% of that space I can account for. It's not doing super great. So 7% error every time in every single prediction, and 69% could be a little bit better. So we always want a low S and a high R squared to know if our line is doing well. So that, my friends, is just about everything in chapter 3 in 5 minutes. The only thing we haven't talked about are outliers. So let's take a quick peek. If I were to add some outliers to this data set, this would be an outlier. Why do you ask? Here's the data. That's a big residual and it doesn't fit the pattern. This point, if I added it, would be a high leverage point. It fits the pattern, but it's fairly disconnected. Both of these points influence the data because they'll change the R value based on if it's farther away or closer to the pattern, and they'll change the slope based on if the line has to tilt to catch the point or if it has to slide to catch the point. So this kind of point would cause the line to tilt. This kind of point would cause the line to slide. And that, my friends, is officially everything in chapter 3.